Maths educational video. Let's talk about the integration of vector value functions. In our introductory video, we define a vector value function, which is essentially a vector of functions. The three components are all functions of some unknown variable, in this case denoted by t. And we also talk about differentiation in the intro video. The derivative of r is simply the vector of derivatives, f prime, g prime, and h prime. Now when it comes to integration, we would like to do the same. Integrating the individual components. As you know, there are two types of integral, the indefinite integrals, the one without integration limits, and the definite integrals. For the case of indefinite integral, we expect to get arbitrary constants for each of the integral that we do. I'll show you a numerical example later. Just a remark on application. We recall RT denotes position vector, R prime the velocity, and double prime the acceleration. In some application, we are not given RT directly. Instead, we could be given the R prime. So we have the velocity vector. And we can recover or we can obtain the position vector by simply integrating the velocity vector. We can do the same to acceleration vector if we wish to get the velocity vector. So this will be illustrated in the numerical example that follows. But before that, we define definite integrals of a vector value function, which is done in the same way, integrating the individual component functions. Let's look at a numerical example. Here we have a moving particle whose acceleration vector is given by this. So you only have the acceleration vector. And we wish to find the position vector of the particle. So obviously we have to go through 2 rounds of integration. So first, we integrate r double prime, which is the acceleration vector given, once to get r prime t, which is the velocity. So we will integrate these 3 component functions one by one. And that will give us this vector. Notice there are 3 arbitrary constants, each coming from one integration. Make sure you use different letters because these 3 constants are not necessarily the same. How do we find A, B, and C? We are given the initial velocity. Initial means t equals to 0. So when you substitute t equals 0, this vector will be equal to the initial velocity that we are given. So you can form this equation, and from which we can find A, B, and C. So with A, B, and C found, we can now plug them back to R prime t formula. And now we will integrate R prime t to get RT. And again, this time we get arbitrary constants, say P, Q, and R. Now make sure you do not use A, B, and C again. In order to find P, Q, and R, we need the initial position, which we are given. This is 1, 0, 1. Equate 1, 0, 1 to this vector when t equals to 0. Form these equations and solve for P, Q, and R. So P is 1, Q is minus 1, R equals to 1. Plug them back to the formula for RT, and we are done. Just a quick remark. So far we have been talking about space curve in 3-dimensional space. Obviously, if you are only in the 2-dimensional space, all you have to do is to remove the third component. Everything else will remain the same.